They said it would never happen at scale, that solid-state batteries were a dream reserved for laboratory press releases and investor decks designed to move stock prices, not move cars. For more than a decade, the biggest names in the industry, Toyota, BMW, QuantumScape, Solid Power, poured billions into the promise. They held conferences, they published roadmaps, they set deadlines that quietly disappeared from their websites the following year. Toyota alone has been chasing this technology since the early 2010s. They have the engineers, the patents, the capital, and the institutional obsession of a company that understands what losing a technological race actually costs. And even then, they still failed. While Toyota was refining promises, while QuantumScape was burning through cash and pushing production timelines into the next decade, while the entire Western battery industry was treating solid-state as a future tense technology, something was being assembled on the other side of the world, quietly, systematically, without the press conferences and the theatrical keynotes. A partnership between two companies that already supply batteries to half the cars on the planet was working on something that, if it holds up outside the lab, doesn't just advance the game, it resets it. And that's when everything started to slip out of control. The announcement came from Chery and CATL, and if you only know CATL is a name you've seen on an earnings report, let's be precise about what that means in real terms. CATL is currently the largest battery manufacturer on the planet. They supply Tesla, they supply Volkswagen, they supply BMW, Ford, and Mercedes-Benz. When CATL says something is coming, the entire electric vehicle industry pays attention because CATL is not a startup making promises from a rented conference room. They are the infrastructure. And now, paired with Chery, they're announcing a solid-state battery headed for mass production with numbers that look on the surface like a fairly significant step forward. 500 watt-hours per kilogram. 1,300 kilometers of range on a single charge, a recharge time of approximately 10 minutes, safe down to -30 degrees Celsius, and a projected cost that, according to the announcement, comes in below the current market benchmark. That's where the trap is, because the benchmark they're quietly targeting is not a generic lithium-ion cell from a Tier 2 supplier. The benchmark is the Blade battery from BYD. And BYD is not a distant competitor. BYD is currently the global leader in electric vehicle sales, and the Blade battery is the single most important piece of technology holding that position together. If you followed this space for any length of time, you know what the Blade represents. It was the moment the industry had to stop dismissing Chinese battery technology as derivative. It survived the nail penetration test without fire. It survived without explosion. It changed the conversation around LFP chemistry from cheaper but limited to reliable, safe, and scalable. That argument worked. The Blade battery became the foundation of BYD's entire commercial strategy, and for a long time, it looked unassailable. And this is just the beginning. The Blade battery runs on lithium pyrophosphate chemistry. Its energy density sits between 160 and 180 watt-hours per kilogram. In real-world use, a BYD vehicle equipped with the Blade typically delivers somewhere between 400 and 500 kilometers of range. Charging takes between 30 and 40 minutes at a fast charger, which is not slow by current standards, but is not a 10-minute stop either. In cold weather, the chemistry shows its limits. A 30 to 40% drop in range at sub-0 degrees is the known trade-off of LFP. The safety profile is excellent. The cost is the lowest in the segment. That combination is why it dominates. Now, look at what the Chery CATL announcement is claiming. 500 watt-hours per kilogram against 160 to 180. That is not an incremental improvement. That is a complete reclassification of what a battery pack is capable of delivering. At that density, the architecture of the vehicle changes. The size of the pack needed for a given range shrinks dramatically. The weight drops. The space reclaimed goes back to the passenger cabin, the cargo floor, the chassis dynamics. And the 1,300 kilometer figure, even accounting for the optimism built into the Chinese CLTC test cycle, translates to an estimated 900 to 1,000 kilometers in real-world use. That means a driver in most major markets could complete 2 days of normal driving before reaching for a charging cable. The anxiety that has defined EV adoption since the beginning, the constant background calculation of range versus destination, functionally disappears. But what comes next changes everything. 10 minutes to recharge. Think about that number in the context of what charging anxiety actually is. It is not about running out of energy. It is about the time cost of recovery when you do. A 30-minute charge session is already better than it sounds to most people who haven't experienced it because you combine it with something: coffee, a bathroom break, a meal. But 10 minutes eliminates even that consideration. 10 minutes is shorter than most fuel station stops when you factor in the full sequence from exit ramp to back on highway. The psychological barrier between internal combustion refueling and electric recharging, which has been one of the most persistent friction points in EV adoption, gets compressed to nearly nothing. That changes the entire game. And the cold weather performance deserves its own moment. Negative 30 degrees Celsius with guaranteed functionality, not degraded functionality, guaranteed operation. The Blade battery's Achilles heel in Nordic markets, in Canada, in the northern United States, in high-altitude regions, is the temperature sensitivity inherent to LFP chemistry. That trade-off has been managed, but never eliminated. The solid-state chemistry, by removing the liquid electrolyte entirely, addresses this structurally. There is no liquid to freeze, no ionic conductivity to collapse in the cold. The thermal profile is fundamentally different. This is where it becomes uncomfortable. For BYD, this announcement is not background noise. CATL and BYD are direct competitors in the battery supply chain and in the vehicle market simultaneously. They are two companies fighting for the same customers, the same contracts, the same shelf space in the global EV industry. The Blade battery is BYD's product. It is BYD's argument. It is the reason OEMs look at BYD cells and see a credible alternative to CATL. If CATL is now able to deliver a solid-state battery in mass production with superior density, superior range, superior thermal performance, and a cost at or below the Blade, then BYD's central technical argument weakens. One does range within constraints. The other removes the constraints entirely. This is not a comparison. This is a generational gap. The Blade doesn't get demolished in a single announcement. That's not how industrial transitions work. The supply chains are too entrenched, the contracts too long, the manufacturing capacity too established to flip overnight. But the direction becomes clear. And in this industry, direction is everything. The companies that miss the direction don't fail immediately. They fail slowly, then suddenly. And this is where the industry loses control of the narrative. Because here's the thing about a 10-minute charge and 1,000 kilometers of real-world range arriving in a mass-market vehicle from a manufacturer backed by the world's largest battery supplier. It doesn't just pressure BYD. It pressures every assumption the global automotive market has built around electrification. The infrastructure arguments get harder to sustain when charging time approaches parity with refueling. The range anxiety dissolves. The cold climate adoption resistance softens. The consumer psychology shifts, and when consumer psychology shifts, capital follows. And when capital follows, the OEMs that had quietly planned to delay full electrification commitments find themselves in a market that moved without them. And this changes the entire game. There are legitimate questions that remain. The 1,300-kilometer figure comes from the CLTC cycle, which is the most optimistic of the major testing standards. More generous than the European WLTP, and significantly more generous than the NPA cycle. The gap between CLTC and real-world results is real and should not be papered over. The production scale is unconfirmed. Announcing mass production and delivering it in industrial volumes are two different events, and this industry has a long memory for solid-state timelines that slipped. The validation outside controlled environments takes time. These are not small asterisks. They are the difference between a paradigm shift and another impressive press release. But they are also, notably, not reasons to dismiss the announcement. They are the questions that the next 12 to 18 months will answer. Toyota spent over a decade on this. Think about what that represents. the most methodical engineering organization in the history of automotive manufacturing, with unlimited budget, with institutional commitment, with a corporate identity built around the idea of doing things right before doing them fast, and solid-state remained out of reach at scale. Now, CATL, which already manufactures at scale Toyota's battery division has never approached, is claiming to have crossed that threshold in a partnership with a volume manufacturer. The callback matters here, because if CATL has actually solved the scaling problem that Toyota could not, then what the industry assumed would take another decade may arrive before the next model cycle is complete for most legacy automakers currently planning their electrification transitions. And that is the real disruption. Not the battery chemistry, not the range number. The disruption is timing. The disruption is that the people who planned on having more time may not have it. The market does not wait for stragglers. The consumers who were told to be patient will simply stop being patient the moment the better product is available. And the manufacturers who hedged their electrification bets on the assumption that the technology ceiling was further away than this announcement suggests, they are the ones who will feel this first. You're not watching a product launch, you're watching a potential inflection point in the largest industrial transition of this century. The question is not whether solid-state arrives, the question is whether you understand what it means when it does. The problem isn't that this technology is coming, the problem is that most people are still measuring the future by the standards of the past.